Alrighty, let's solve this. I'm going to do it two ways. I'm going to do it my favorite way first and use conservation of energy. That's my favorite thing to do. So here's this thing going down this hill, right? We've got the height of it, right? There it is. It's a marble. There we have it. Okay, and basically MGH is going to turn into translational kinetic energy and rotational kinetic energy. Right? And then we always make these substitutions. Okay, we always substitute for this guy. We're using this relationship. V is omega r. So therefore omega is V over r. So we're going to substitute that in for this guy. Whoops. And then I, because it's a marble, right, we're going to substitute I is 1/2 mr, whoops, sorry, 2/5 mr squared. Okay. Can you see that? That's a 2 and a 5. There we go, right? We're going to substitute that one in for here. Okay. I will tell you on the assessments, I'll tell you what this formula is for this moment of inertia. It'll always be something unusual, you know, but we can do this. This is easy. Okay, so basically what we're saying, potential energy turns into two kinds of kinetic energy, the translational and the rotational. So our next step is MGH is 1/2 mv squared plus 1/2 times 2/5 mr squared. That's what I is. I just substituted for I. And then V over r squared, right? Okay, so now what we can do, we can cancel an m out of every single term, right? And notice that the r is squared, right? So this will end up being V squared over r squared. So the r squareds go away. And we end up with GH equals 1/2 V squared plus 1/5 V squared. That's all that's left, right? So, and by the way, the mass it'll always cancel, right? I'll tell you the mass, but we don't need to use it, right? And the r is canceled, so I'll tell you that in the hopes that someday some kid will actually use the r. You could do it. I mean, you could at this point plug all the numbers in, but you really don't want to. Okay, so now we're set. Now let's go GH is 1/2 V squared plus 1/5 V squared, right? GH would also be, what is this? So it's our common denominator, I guess 10, is that right? So it would be 5/10 V squared plus 2/10 V squared. Now if you can't fraction, your calculator actually can fraction. You can set up this, and you can set up this, and then you can go math, I think it's math 1 to fraction, right? Okay, so obviously GH is 7/10 V squared. V is therefore 10/7 GH, and V must be the square root. And that's our answer right there. Okay, this is my favorite way to do it because the setup is so I can remember this, right? This is just kinetic energy and rotational kinetic. This is a simple substitution as well. But anyway, I'll show you how to do the other way here in the next video.